Hello, and thank you for joining us today. We're ONICON, and today we're going to be talking about our newest product that was released last year, the FT-3500, our insertion, mag, and flow and BTU meter. So to start off, I'm Mike Rivers, the Director of Sales and Marketing, and I'll be presenting today with Brian Woodruff, one of our regional sales managers, and then answering questions towards the end will be supported with Luis Ojeda, our senior product manager. So if you do have any questions today, please use the question box through this platform, and towards the end, we're going to answer as many questions as we can. So to start off, I'd like to just give you some quick background on ONICON and what we call our ONICON difference. We're a U.S. company based here in Florida, and we really take an engineered approach. As you can see, we have a lot of different technologies, and so our approach is we want to use the right technology for the right application. And again, we're measuring water, steam, gas, and BTU measurement. In all of our flow meters, we build and calibrate to the specific application. So you tell me you have a 6-inch pipe, chilled water, average flow is 500 GPM. We build that flow meter, we'll physically put it in a 6-inch pipe and give it a wet calibration, and it'll come with a calibration certificate for that specific application. So I like to tell all the installing contractors, hey, this flow meter was built, calibrated, and factory programmed to that application. So the 10-minute rule. If you can't get the flow meter working in the first 10 minutes, stop what you're doing, call our rep or call our factory, and let's figure this out. So because it should be ready to go out of the box. And probably what we're most known for is our customer support. We have a great rep network for local support around the world. And we also have a full engineering staff here at the factory answering phones. And so we can support everything since we're doing all the right things, choosing the right technology, calibrating it, factory programming it. We provide everything with a 3-year warranty, including what we call our 1-year no-fault warranty. So anything that happens in the first year, you jam it in a ball valve, you hook up the wrong power, you run it over with your truck. Typically you have one person specifying it, one person installing it, someone else powering it, someone else trying to communicate to it. We're trying to protect everybody. Anything that happens in that first year, no questions asked, we'll repair it or replace it at no cost. So today we're going to talk about our FT-3500. This is one of our flow meters in our electromagnetic family. We have our inline series, the FT-31 and 3200. We also have the FT-3400. That's what we call our insertion mag meter with a blind version or no display. But today we're really going to focus on the FT-3500, our insertion flow and BTU meter with display. So why do we love our insertion meters so much? Well, first off, this meter, it's no moving parts. So it doesn't matter about the water quality. It's no wear and tear over time. We're really going to remove the maintenance required over the life of the building. Also, it's a hot tap design, so you can hot tap this into live and pressurized systems. So this is great for new construction, for also retrofit applications where you can't cut into the system. And it's the best overall value for challenging for open loop systems. So you're really getting electromagnetic technology at a great price. It doesn't matter if it's a 2-inch pipe or a 36-inch pipe, you're getting this technology at the same price. So how does this flow meter work? It's using Faraday's law. So if you remember physics class back in the day, we're creating a magnetic field and we're putting a conductor, in this case water, through that magnetic field, and it's creating a voltage. So we're measuring that induced voltage, and that's going to be proportional to the velocity going through the system. So what applications is this technology good for? So we originally designed this for open loop cooling towers. If you think about back in the 80s, all we had was the turbine flow meter. Was great for chilled water, hot water, but not great for open loop systems. So we designed this insertion mag meter to handle those open loop systems. But we've really seen a shift in the industry where people are asking for no moving parts to remove that maintenance required. So this is great for chilled water, hot water, condenser water. Also great for domestic water. It is NSF approved. Really any water application with at least 20 microsiemens of conductivity, so wouldn't be a good solution for like ultra pure water. So why are we using flow meters? And I have a lot of reasons listed here, but I like to really break this down to three main applications. Monitoring, controlling, and billing. It's great to have multiple points of monitoring so you can see what's happening through your system. Also using these flow meters all the time for controlling, whether controlling your chiller plant, controlling your data center, having information to, hey, when do I want to turn on that second chiller? When do I want to have that turn on that third chiller? And then the third one, billing applications. Historically, people would bill off of square footage. Not really quite fair. Especially when you have like you might have one tenant that's only there 8 hours a day, another tenant there 24/7. So we're really seeing more and more people billing off of BTUs. And you can't talk about an ONICON product without talking about the accuracy or the performance. And I like to really encourage, the engineers here to think about three components when talking about an accuracy statement. What is the percentage of accuracy, and what is that in reference to, and over what range is that valid for? And so we see this missed a lot. Yeah, I want a 1% device. Well, 1% of what? And so this graph here on the right kind of demonstrates the difference between a 1% of full-scale device versus a 1% of reading device. So at 1%, they're both at 30 or full scale or 30 feet per second, they're both 1%. But let's look at the accuracy and velocities that we're typically seeing. So in closed loop systems, chilled water, hot water, condenser water, it's typically around 4 to 8 feet per second. So at 4 feet per second, that 1% of full scale device is actually plus or minus 8%, while we're maintaining 1% over that entire range. And then what about domestic water when you're trying to measure, a sink running, a toilet flushing, a shower going? Well, those domestic water applications or makeup water applications can be down to like 1 feet per second. Well, at 1 feet per second, that 1% of full scale device is plus or minus 30%. We're maintaining 2% at the low end. So I like to kind of put that in a quick example because we get this question all the time. Hey, this looks like a 1% device. Can you tell me what the difference is? Well, let's say you have an application and both meters can read 0 to 5,000 GPM, but you're trying to measure 300 GPM. Well, a 1% of full scale device is going to be 1% of 5,000 or plus or minus 50. Well, when you're trying to measure 300 GPM and your flow meter is plus or minus 50, that's not very accurate. So all ONICON meters is a percentage of reading device. So in this case, 1% of 300 or plus or minus 3 makes a big difference. And of course, so where does this accuracy, where's the performance coming from? Talked about the calibration. So all of our flow meters are wet calibrated, come in with a calibration certificate. And here's a picture of one of our many calibration loops here in Florida. And now I'm going to pass it off to Brian.
Yeah, thank you, Mike. So we want to talk about the features of the FT-3500. So you can see what's great about the insertion meter is the wide range of pipe sizes that we can accommodate. So it's going to be 1.25 inches all the way to 72 inches. Plus, as Mike mentioned, we're able to achieve that accuracy statement of plus or minus 1% of the reading. As well as you can see the enclosure. So this is going to be a remote mount that comes standard with 25 feet of cable. And you're able to see that the enclosure, the actual transmitter is NEMA 4. So it is able to be installed outdoors, and that touchscreen display is UV rated. We just ask that you don't install it in direct sunlight. And then the sensor is NEMA 6, as well as he mentioned it's NSF approved. So you see there that the wetted components is stainless steel. The input and outputs of the signals, you have 2 analog outputs, and then you have 2 temperature inputs. So you have a BTU option available for this model. And you also have the digital inputs, 3 of those, and frequency. And this is CE conformity with the UL 61010. So what's great about this meter that when we designed it, we had the networking in our mind for how we designed it. And we actually updated the stack now. So you're able to provide the BACnet and or Modbus, whether that's RS-485 and or IP. And if you notice there with our alarm settings, you can actually set the upper and lower limits for like backneck objects. And then as you see there on the table, those are some of the objects and registers available on that serial communication. So the touchscreen display, this is what we're very excited about. It's basically like your cell phone. It's very user-friendly and configurable. You can actually set it up to see the screens that you would like to provide the information that's going to be useful for you or those with that eye-level display in front of you. From flow reading, energy and temperature, you got totalization, whether that's 24-hour, 30-day, year-to-date, and any active alarms that is currently in that state. The meter info, this is a great feature to have. We've seen it several times in the field when you go up to the flow meter and the hanging display tags that we have been removed and you have no information outside of the serial number that you can provide to our tech support team. Well, now we actually have a meter info display available, so you're able to see the calibration information, the date, the serial number, and all that information is great to have. And when Mike was talking about the warranty we provide, you can still go in there and see if you're still under that 1-year warranty, if you're still under that 3-year manufacturer warranty, plus all the communication settings as well. Next. Field configurable. So again, we like to listen to our customers. What are they saying about our products? If you remember the standard, the F-3500 previously, it was a bit of a challenge to try to get any type of field configurable attributes done. So you'd actually have to contact ONICON, you'd have to fill out a form, we'd have to submit for an S19 file. Then when you receive that file, you'd have to take a laptop, plug in with a DB9 connector to do any type of changes. So we're able to do that on the fly in the field now. So you can see in the bottom right-hand corner of the screen, the pipe configuration settings. So say you did order it for a 6-inch, and once you got it out in the field, you realize it's an 8-inch pipe, you can quickly go in there, change the settings, and you're not playing or messing with the calibration because we're actually doing it's a velocity measurement. So you're not messing with the calibration when you do those changes. So great added feature that we have there. As well as alerts, so any type of an error alarm that you're able to see or you really don't know what's going on with the meter, you can quickly go into one of the screens and see those failure modes. As well as when you contact the tech support team, this is great information for us to be able to troubleshoot over the phone to see what's going on. And in the bottom right hand of your screen there, you see that you're able to provide a waveform. So if you notice there, the green waveform is on electrode 1 that is actually communicating correctly, and then you see electrode 2 does not, providing any data. So it's a great diagnostic menu to dive into what is actually happening lifetime with your meter in the field. And now I'll turn it back over to Mike.
Thanks, Brian. So again, this is not just a flow meter. This is actually also a BTU meter. So if you think about our older product, the F-3500, that would have to be tied to a System 10 or System 20 BTU meter. Now, all you will need is this next generation FT-3500. So I kind of like to talk a little bit story about how ONICON got into BTU measurement. You know, if you think back about like the early 90s, you know, what happened was we only sold flow meters, and you know, we might get a phone call 3 years after shipping a flow meter, and they say, hey, your flow meter's wrong. And then we're like, well, hey, we built, calibrated it for your specific application. Why do you think the flow meter is wrong? They're saying, I'm using this for BTU measurement and my BTUs aren't adding up. And so that in that case, you know, maybe they're just using an ONICON flow meter, 2 temperature sensors back to their building management system to calculate BTUs. So this one, ONICON got into, really dove into understanding where these inaccuracies were coming from. And we found all these different sources of error from the flow meter, the temperature sensors, the calculations, and so forth. But we found out a lot of the inaccuracies was coming from the temperature sensors. So, you know, if you're using standard thermistors, RTDs, well, say it's a ½ degree off in the supply, well, and then a ½ degree off on the return. Well, when you're looking at that delta T, that's potentially 1 degree off, and 1 degree off in a 10-degree chilled water system, that's 10% air before you start considering the air from the flow meter and the calculations and so forth. So what ONICON does is we're not just providing a calibrated flow meter, but we're providing calibrated and matched temperature sensors. So even if it's a little bit off on the supply, it's going to be a little bit off on the return in the same exact direction, which is providing a very accurate delta T measurement, which is where that BTU measurement is coming from. So now you have the calibrated flow meter, calibrated and matched temperature sensors going back to the transmitter, and our transmitter is doing that BTU calculation so many times a second. And for our control contractors out there, now, when BTUs aren't adding up, who do you blame? The flow meter, the temperature sensors, the person calculating BTUs? We want to take ownership of all of that and providing a complete calibrated BTU system. And now back to Brian for the installation procedures.
All right. So we want to touch on the installation procedures. So to achieve some of those items that we're talking about with accuracy, where we install the meter is critical. So we encourage you to visit our ONICON website for installation procedures and/or our YouTube channel. And if you're out in the field and you're having a difficult time, or if you don't have the manual, the great videos that accompany these for installing them. As well as when you order our meters, you can actually purchase the installation kit through ONICON when you place the order. We have two different versions of dry tap kit, so those are great for new build, new construction. It comes with a 1-inch ball valve, so our meter is readily available to thread in, and you're good to go with once you put it to the insertion depth. What's great about it is once you're there and you've commissioned it, and you're ready to go later down the road, if you need to remove that and send it back for recalibration or anything, you have that ball valve there. You can easily remove it, close the ball valve, unthread it, and you're ready to send it back to ONICON. As well as on the right, we have the hot tap kit. So this is great for a live pressurized system. It's actually an 1.25 inch ball valve, and that's for that hot tap drill to thread in, and you're able to drill into a live pressurized pipe. Next, a couple of things you have to keep in mind when we're talking about electromagnetic technology is when you're dealing with those non-conductive pipes, anything from PVC, HDPE, Aquatherm that we're seeing quite often now, you have to think about the grounding rings and/or grounding probes that you will need to order for our flow meter to operate correctly and ground the meter. So the flanged is going to be the grounding rings, and then if you do need the probes, say it is in a already existing pipe, you can hot tap the probes as well. Next, we're going to talk about the straight run requirements. So it's kind of nice there on the right. That's typically what we dream of when you call us, that we see, but typically we're dealt with the mechanical room that you see there on the left. So what we just say is just get ONICON and/or your rep involved so that we can kind of help you find the best location for the meter to be installed. I know you've heard the 10 up, 5 down. That's typically the industry standard. It's 10 pipe diameters upstream and then 5 pipe diameters downstream. What they don't tell you is what that upstream obstruction is. So if you hear the 10.5 for our flow meter to achieve that 1% accuracy plus or minus, that's actually followed by just a 90-degree bend with roughly 10 pipe diameters of straight run. So definitely the upstream obstruction is critical. So whenever you run into that scenario, it's not that our flow meter will not operate. It's just a matter of, like Mike mentioned, what are you using our flow meter for? Are you just doing it for monitoring? Are you doing for staging chillers? Or are you actually billing off of it? So that's when you need to get us involved. And there's certain items that we try to avoid: modulating valves, inflowing T's, outflowing T's, and so forth. And that can greatly increase that straight run obstruction. So if that's what you're dealt with and you have an ample amount of straight run, we typically go with the 80% upstream and 20% downstream in those specific scenarios. And when we're talking about straight run, this is just a velocity profile that you see. When we talk about swirl and or turbulence that happens after a bend, this is where you see where we want to install our meter is actually where you get to that laminar flow in the HVAC application. Next, we have some CFD modeling that we have, just showing you some of that turbulence that we're talking about after a 90-degree bend. So this is an example there on the screen. If you notice there that it's our insertion electromagnetic meter installed. And then considering that insertion meter, you know, you're only in a small portion of that pipe. So we're usually in the upper 1/3 or bottom 2/3. So obviously you don't want to be too close to the pipe wall because of the friction. So that's why it's so critical to achieve those accuracies. Next. So this is just a live demonstration of CFD modeling showing the swirls after. This is actually multiple bends out of plane that it shows here. And this is just another viewpoint showing it. It's actually interesting to see it with all that swirl action. So, all right, so straight run items that we do try to avoid, like I mentioned, is control valves, inflowing tees, multiple bends out of plane. Things that are workable are outflowing tees, pipe reduction or enlargement, and single bends. And ideal is the longest amount of straight run. And why we mention that is if you think about, we've had run-in scenarios, if you think about a closed loop system, everyone's always so focused on the supply side, not even taking into account the return side, where if it's a closed loop system, you should have that same flow rate on both sides. So definitely there's ways that we can work with you to find the best location for our insertion flow meters. And now it'll be back to Mike. Close up. We're almost done.
Thanks, Brian. And just to kind of recap, and that's a high level of our FT-3500. If you have more questions, encourage you to contact us or your local rep. But just a reminder, a lot of different technologies. This is just one technology in our tool bag. We really like to take that engineered approach. I showed you a picture of our calibration loop. Again, all of our meters are wet calibrated to your specific application. That's where the accuracy and the performance is coming with that calibration certificate for your specific application. So all of our installing contractors out there, the 10-minute rule, if you can't get it working in the first 10 minutes, please stop what you're doing, give us a call, because it should be a plug and play. And local support with our reps, willing to go on site. As kind of Brian mentioned there, one of the more challenging things is finding a good location. Let's find the best location to give the best opportunity for the meter to perform. And again, backed up with our 3-year, including our 1-year no-fault warranty. So, you can trust anything that happens out in the field in that first year, we'll repair it and replace it at no cost. So looks like we have a ton of questions coming in. So we're going to take the 10 again. If you have any questions, use that question box through the platform here. And we're going to go ahead and shut this down and start answering some questions. All right, so let's see here. First question, how often do you have to recalibrate your flow meters? And so that one, my answer is it depends. It depends on what you're doing with the flow meter. So I can kind of give you a few examples. If we have some customers that are billing tens of thousands of dollars every month off of our flow meters. So that accuracy and that paper trail to that calibration certificate is extremely important to them. So we see them calibrating meters every 6 months to every year. Kind of on the opposite side, we've had meters come back after 20 years, and it's like, hey, our flow meter hasn't come back in 20 years. Let's take a look at this, and it's still within a couple percent of how it was shipped. So those are kind of both two extremes. But what our recommendation would be, especially if you're just monitoring or controlling, is at least go touch the meters every 1 to 3 years. And so I like to kind of separate that terminology of calibration versus validation. So for something to be recalibrated, it needs to be compared to a standard that's 4 to 10 times as accurate. So you can't really recalibrate in the field very easily. So that's typically that's why I love those insertion meters. You can take it out, shut off the ball valve, remove the meter under pressure, send it back to ONICON. In a couple days, we'll get it recalibrated with a new calibration certificate, get it back in your hands in a couple days. What is more commonly done in the field is a validation. So a few different ways to validate our flow meters in the field. One could be using our FT-3400, our portable ultrasonic, clamping that downstream of the flow meter. And hey, that's within a few percent. I can validate that this flow meter is still accurate. Another opportunity would be take another one of our insertion meters, put it in the same location. Hey, it's reading the same percent. You can kind of validate that that meter's still within calibration. Let's see, next question. Is this 1 year no fault warranty and 3-year warranty applicable for the FT-3500 or your complete product line? And it is that is an ONICON standard for our complete ONICON product line. 1 year no fault, 3-year manufacturing warranty. Let's see, next question. If I have ultra pure water, low conductivity, what meter should I use? So I kind of mentioned FT-3500, great solution for water measurement, clean or open loop systems, but it does require that 20 microsiemens of conductivity. So for ultra pure water applications, we have a few different options. Our insertion turbine meter can read down to like 2 to 3 microsiemens. But what's great, we typically are using is our clamp-on ultrasonic meter or our wetted ultrasonic meter. So that ultrasonic technology doesn't require any conductivity for measurement. All right, next question. Can you measure flow of a non-water based liquid? So I think it depends on the liquid. We can certainly do glycol, ethylene or propylene. I guess if it was outside of our typical HVAC application, we'd have to dive into that. If it were, technically, if it has conductivity, it could measure it. But if you have a specific application you're asking about, feel free to reach out. We'll dive into that specifically.
Hey, Mike, I got one we'll take. It's going to be the lengths of the remote cable. Good question. So it comes standard with 25 feet, as I mentioned, and then it's available up to 200 feet. Typically, we don't see any requests much larger than that, but if you do need it longer than 200 feet, you can contact us and we would be able to accommodate.
All right, another good question. Are the FT-3500s able to set up a daisy chain configuration for IP integration? And so this is a great question. Currently, it's only for the RS-45. Can you do the daisy chain? It doesn't have the input for an IP integration for a daisy chain, but this is the second webinar where we've had that question. So we've already taken that back to product management and going to take a look at that to see what could be done in the future. If this is super important to you, we would love to hear from you to kind of understand what the application is, how often you're seeing this, and that will help us prioritize how quickly we can get that into our new NPD process.
We have one, I believe Luis answered, but I don't think the group can see all these. So the question was, can these meters be used for ANSI C715-18 cold water meters, electromagnetic type for revenue applications and billing purposes? So the C715-18 calls for an inline ultrasonic or electromagnetic meter. The FT3500 complies with the uncertainty requirements, but its installation is insertion style. So we would recommend our FT3200 or our FT4600 to fully comply with that standard.
All right, here's another good question. I'm having a hard time finding straight run. What should I do? And the first thing is call your rep or call our factory. Take pictures, create a sketch, let's look at drawings, find a way to kind of, sometimes the reps can go on site to find the best location. We do our inline style mag meters for that 0.2% required 3 up and 2 down, but it will still be within 1% with no straight run. So that's another technology that could be considered when you have no straight run available at all. But realistically, even if you can't find that 10 up and 5 down, that insertion mag meter is still going to work. So depending on what you're trying to do, maybe it's just a monitoring point or trying to measure, the minimum flow into a chiller, for example, you're still going to get a great performance even with limited straight run. But what we recommend there is let's find the best location possible, especially for those retrofits where it's more challenging to redo piping or cut into the pipe. Let's just find the best location. What we're trying to avoid is, hey, there was all this straight run. Why'd the flow meter go there? Oh, well, the ladder was there. Well, no, let's find the best location, give it the flow meter the best opportunity to perform.
Next one I'm seeing is, can the FT3500, when purchased as a flow meter or flow only, be converted in the field to flow and energy? I don't know if Luis is there, if he wants to jump on if I misspeak here, but my understanding is when it's ordered as flow only, it would actually need to come back to the factory and get recalibrated and firmware updates to accompany that energy meter.
Let's see. If we have an existing flow meter with an older model, the F3500 with a BTU meter like a System 10, is it possible to upgrade to that smaller display that comes with the FT3500, or do we have to replace the entire assembly altogether? And so you can't add the new display to an old F3500, but the FT3500 does get installed in the same ball valve as our insertion turbines or the previous version, the F3500. So you are able to install the new version in the same ball valve assembly.
There's a good question here too. How do you calculate the energy cost once you have a BTU value? The difficult part is already done by acquiring the FT3500 BTU, which is going to give you a precise BTU measurement. So on the top of that BTU measurement, you have to add the COP of your energy plan, which is basically the thermal kilowatt to the electrical kilowatt factor, and then multiply the kilowatt per dollar in your area.
And kind of on the same lines that Mike had addressing, one question is, do I need to add install kits and temperature sensors to an F3500? So I do want to clarify, the F3500 is the old version. BTUs are not available in that model, but the new FT3500 with the transmitter is BTU capable. And yes, you will need to purchase, same thing, it'll be the dry tap kit or installation, dry tap or hot tap kit for the temperature sensors as well.
All right, here's an interesting question. Any opinion on when calculating flow based off of DP sensor versus a flow meter? And, I think it's going to be challenging to get anything more, as accurate as a wet calibrated flow meter. If you think about what's happening with a DP sensor, so, if you're doing a DP across of a pump, for example, that pump curve isn't a calibrated pump curve. That's a pump curve based on, on average of all those other pumps that are being manufactured. Or the other example would be like a DP across of a chiller. Well, yeah, when that chiller was 100% brand new and clean, you might get a decent DP measurement. But as the life of the building, those spindles get clogged up and so forth, that DP is going to change. So I think DP is a great tool to help commissioning flow meters in your system, but I don't think it's going to be, you're not going to get the same accuracy or performance as you would a calibrated flow meter.
There's another question here. If we have an existing flow meter that is an older model with a BTU meter, System 10, is it possible to upgrade to the smaller display that comes with the FT-3500, or we have to replace the entire assembly altogether? So the FT-3500 and the F-3500 both have the advantage that they are serviceable. So you could remove the old F-3500 and install the new FT-3500. And another good thing about the FT-3500 is that the display have the same mapping of the System 10. So you don't have to change your backnet structure to now implement the FT-3500 into your system. You should be able to connect the new FT-3500 and don't do any changes on the network.
Thanks, Luis. Here's another good question. Are grounding rings required on all FT-3500s? And we actually only recommend it or we require it on non-metallic pipe. So PVC, the HDPE, and so forth. If it's not metallic, we require grounding rings or grounding probes before and after the meter. But if it is a metallic pipe, steel, copper, and so forth, what we've learned is the pipe wall, the pipe material kind of acts as a ground, so it wouldn't be required.
All right, next one is, other than the turbines, what is the main difference between the F1200 and the FT3500? So basically you're going from a moving parts, as you mentioned, the turbines, to no moving parts. So turbine meter, clean closed loop systems, great and more cost effective. Then you have the FT3500 with the remote display that is no moving parts, so good for condenser water, cooling towers, and so forth. Plus, you don't have all the added features. Like, for example, the F1200, basically you can have an analog output and or a pulse from that meter. No serial communication, so you would actually have to purchase a separate display to network that device. The FT3500 has that stack for serial communication been updated, all serial communication available, BACnet Modbus, and so forth. You can bring in additional meters for digital inputs as well. So two complete different models. I would say the biggest difference, like I said, moving parts, no moving parts, and more cost effective for the turbine meter versus the insertion electromagnetic.
So here's another good one. FT3500 compared to a System 40. So the System 40 is a wetted ultrasonic BTU meter. So they're both using the same function: measuring flow, measuring match temperature sensors, calculating BTUs. I would say what's the differences would be the System 40 is only designed from 1/2 inch to 2.5 inch pipe, where the FT3500 is 1 1/4 and larger. So if it's 1/2 inch to 1 inch, has to be the System 40 out of those two solutions. And if it's larger than 2.5 inch, has to be the FT3500 out of these two options. But from 1 1/4 to 2.5 inch, really gets back to I would say the System 40 of the smaller sizes is a little bit more cost effective, but the FT3500 gives you more serviceability since you're able to hot tap that and install it and remove it under pressure rather than a flange meter where you're having to remove it from the system. So there might be some, depending on, is it new construction or how often do I need to recalibrate the flow meters and so forth, that might direct you to one technology versus the other. All right, here's another good one. Will the FT3500 display take an output from another flow meter? And the answer is no. This FT3500 display is really designed just for the FT3500 sensor. Um, However, if you did have a different other flow meters and you're looking for a display, that's where we're going to recommend looking at our System 10 or System 1000 BTU systems. So the System 10 can just do one application for BTU measurement. The System 1000 is another new product of ours. Well, that's probably going to be the next product of our webinar series. It's a multi-channel BTU system that can take up to 2 different BTU channels, so chilled water, hot water, 2 chilled waters, 2 different BTU applications with additional analog inputs. You can hook up to 8 different flow meters to that new System 1000. So keep it on the lookout for the next webinar series on our System 1000.
All right, we have one. It says you have outlined the reasons why the electromagnetic meter is superior to other flow meters. Seems almost like the ultrasonic meters might be a thing of the past. Are there applications where the ultrasonic would be better than the electromagnetic? Yes. So depending on the application, like I said, different flow meters for the application. A good example of those right off the top of my head is RO water or DI water. So if you think about electromagnetic, it actually needs some conductivity to take the measurement. Ultrasonic does not. It actually uses speed of sound, and like glycol would affect that and so forth. So that technology is great for non-conductive applications, as well as if you think about our wetted ultrasonic, you're limited on pipe sizes being from 1/2 inch to 2.5 inches, and electromagnetic insertion goes all the way up to 72 inches.
There's another question here. Do we need different installation kits other than installation one while installing on a stainless steel pipe for the FT3500 and the turbines? So when you're filling out the order form, we ask you what type of material is the pipe. And if you say that it's a stainless steel, we're going to provide you installation 18 instead of installation 1. The main difference between them is that the threaded weld outlet is made for stainless steel.
Or it's another good question. Can you recommend a reference text to calculate the BTU cost? And unless you guys do, I don't have a particular text, but we do have presentations that kind of help assist with this. So if you have a specific need, please contact us offline here or contact your local rep. And we'd love to sit down with you, kind of go through what your specific application is. And there's a few different ways to calculate BTU cost. You can either do it through COP, the COP calculation, which is the coefficient of performance of like your chilled water system or chiller plant or chiller, whatever it may be. The other would be a percentage. So, hey, what's the total percentage of BTUs? How much is going to a specific tenant? So a few different ways to handle it. Happy to walk you through it, discuss that specific project with you. All right, let's see. This was a good reminder from our marketing team. I want to thank Heather and Emily for helping us put this on. But just a reminder, we do have our catalog sheets, Revit files, manuals all on our website. So www.onicon.com. All of our information on this new product is there. Another question looks like the Siemens was asking about FLN protocol. Is that P1, Luis?
Well, it's similar. So what we are going to recommend is there is gateways that people can use that takes BACnet or Modbus to the any protocol that you want. So we recommend to use the advantage of the FT3500 features and install the gateway that is needed to any other different protocols.
Thank you, Luis. And I think we're done. Like maybe just one last question. with no moving parts, what's causing fouling or degradation of the sensing element? And I've been amazed about pulling this flow meter out, and even in a clean closed loop system, not everyone's able to use the water treatment as it's designed, and you get like a kind of a sludge. And this meter is still working even in some very sludgy water applications. So I would say there's nothing really there to foul. That's why we love this technology, really robust in open loop systems. However, that recalibration and so forth is more, that kind of give you that warm and fuzzy, having that paper trail, that calibration. There's, I guess, the other element there would be if you actually had hard particles hitting the sensing element. I wouldn't, depending on the application, that might be the one application where you might want to consider like an inline mag meter where there's actually nothing in the flow stream, but we don't really see that very often.
Right, and ONICON always pick better materials than the pipe. So the material of the FT-3500 is stainless steel, which is more noble than the pipe material. So when there is folding effects, you won't see degradation in our material, but you might see degradation in the pipe material, which will cause a bigger problem.
All right. FT-3500 for 3 inches smaller, suitable for HDPE pipe. It is, correct? Yep.
Yes.
Yeah, it's been calibrated, designed for any of those pipe materials. Again, HDPE is just going to require grounding, either grounding rings, grounding probes before and after the meter.
And one of the good features about the FT-3500 is that the screens is so intuitive that if, let's say, we program this meter for a specific pipe, you get to the site and it's a different pipe, it only takes 5 seconds to change the pipe size. There is no requirements of a computer. It just go to the menu and you're able to change to the specific pipe size, full scale that you need on this product.
And then, not sure if we answered this one, so I'm going to answer this last one before we let everyone go. Is there a trade-up program in place for D100 F3500s to this new FT3500? I wouldn't say we really have a program in place, whether it's a turbine F3500, but please contact your local rep, and depending on what your situation is, we'll come up with a plan on how to get you up to this next generation newest product. So just want to, again, take the time and thank everyone for participating today. Always love your feedback, how the webinar went. If there's things that you didn't get answered, let us know. Contact your rep, contact us. And we want to continue doing these webinar series. So as I mentioned, we're already working on the next one is going to be on our System 1000. But what else would you like to see? Happy to do this. And if your office or you have a specific need, with our rep and our regional sales managing team, happy to come into your office. We have presentations for PDHs and so forth. So please contact us, and looking forward to hear from you. Thanks again.
Thanks, everyone.
Thank you.